So we're talking about angles of elevation and depression. We have our little doodle here. So what is an angle of elevation? What is an angle of depression? Let's pretend that this is, I don't know, Rapunzel, and she's up in her tower, and she locks eyes with the prince. Is this Prince Charming? I don't know what his name is. They lock eyes, and, you know, he's like, wow, I want to rescue her, and she's like, I think I could just jump down, but let's make this interesting. So she's just hanging. The angle of elevation is the one we're going to start with. The angle of elevation is between the invisible horizontal line, which is always just horizontal. Where is it? What way is it shaped? Whatever. It's a horizontal line. End of story. It's between a horizontal line and the line of sight. So the angle of elevation is how much, Prince Charming over here, how much he had to elevate his chin to lock eyes with the princess or Rapunzel. Right here, theta is the angle of elevation. Now, what about the angle of depression? Common misconception is that the angle of depression is over here, but that's not the case. The angle of depression is actually also between a horizontal and the line of sight. It is how much Rapunzel has to drop her chin so that her eyes can lock with the prince. This line is called the horizontal. That's it. We're going to call it that. This is the line of sight. Now, one more thing that we could actually mention is that there is actually a relationship between these two angles. The angle of depression, we'll call this theta sub d, and the angle of elevation, theta sub e, have a relationship. What is that relationship? Well, this horizontal line and this horizontal line are obviously parallel. That would make this line of sight a transversal. What do we know about these angles? For one, they are alternate interior angles. And alternate interior angles are congruent when the two lines are parallel. So the angle that the prince must lift his chin and the angle that Rapunzel has to drop her chin are congruent. They are the same measure. So the angle of depression and the angle of elevation are congruent angles. Do not be that person who draws the angle of depression there. No good, okay? It's how much you drop your chin, how much you drop it, it's how much it comes down. Reference this picture. Maybe you drew it a little bit less elaborate. This is assumed to be a right angle. Sometimes it's useful to add in this extra arbitrary line right here, and keep in mind that that's also going to have a right angle. And then we can use trigonometry to figure out missing components when we know certain details. I hope this sets you up for the word problems that we're about to do, and we're going to work on 5 word problems next. Example 1, draw and label a diagram. Then, showing all work, solve. A mirror that is 8 feet long is leaning against the wall inside of a home. If the angle formed between the mirror and the floor is 84 degrees to the nearest thousandths, how far is the bottom of the mirror from the base of the wall? Okay, so first thing we need to do is draw a picture. These questions will all require trigonometry, so we're going to have right triangles. It would probably be in your best interest to not even bother trying to make this to scale, because this triangle will be really, really, really skinny if you drew it to scale, and that's just a little bit harder to deal with. The next thing that you should do is label with words what each side of the triangle represents. Now that I have everything drawn and labeled, you want to put a little note, not to scale. How far is the bottom of the mirror to the base of the wall? And the mirror is 8 feet. So I'm just going to switch up my pen color to label my 8 feet is the mirror. My dog just threw his bone down the stairs. And we're trying to see this distance for the floor, so I'm going to call that floor or far, I don't know, we're calling that F. And we can say this is M. When you're solving these, we're going to be using trigonometry. You need to look at what it is you have, what you're working with before you decide which trig function you're going to use. We're really only going to be using either sine, cosine, or tangent. There's no need for the reciprocals when you're doing word problems. We don't need secant, cosecant, or cotangent because the other three can cover it all. You know, it has a combination of two of the three sides. Which sides do we have if we're looking at it from the perspective of this angle? F is the adjacent side. M is the hypotenuse. Which trig function requires us to use adjacent and hypotenuse? That would be cosine. Cosine of theta is equal to adjacent over hypotenuse. Now what we're going to do is just fill in the values we do know and then use algebra to solve for the values that we don't know. Cosine of 84 degrees equals f over 8. How do we get f alone? F is being divided by 8. We need to do the inverse operation. That would be multiply by 8. These two 8s reduce, and we're left with f, how far the bottom of the mirror is from the base of the wall, equals 8 cosine 84 degrees. Now here I can confidently use a nice solid normal equal sign because this is actually the exact answer. I didn't have to round, and this is actually being very precise for me. But the question does say to round to the nearest thousandths place. How many decimal places out is thousandths? That's going to be 3 decimal places out. The 8 does not multiply by the 84. This is important. The way I have it written is exactly how we're going to punch this into the calculator. 8 cosine 84, it already implies that multiplication is going to be happening between the 8 and the cosine of 84. Close my parentheses. If I just hit equals on this calculator, it actually does compute it for me, so that's good. And I double check it does have a D for degrees, and I got my answer of 0.836 yada yada yada. So it's actually very close to the wall, which makes sense. It's less than a foot from the wall, and I believe that's to be expected. You know, a base of a mirror is probably less than 1 foot from the wall. The base of the mirror is approximately 0.836 feet from the wall. So that's what we found right here, and that was this side of the triangle, and that's all that there is to it. So my exact answer, if I needed to find, if directions ever tell you find the exact solution, you leave it like, and that's it. Tom wants to measure the height of the uprights on a football field. He knows the uprights are 10 yards from the goal line. He then walks to the middle of the football field. Tom uses a clinometer to determine the angle of elevation to the top of the upright is just shy of 8 degrees when holding the clinometer 5 feet above the turf. Using 8 degrees for the angle to the nearest whole number of feet, how tall are the uprights? If you ever come across a word problem and you're not entirely sure what everything means because you don't know all those details, look it up, okay? We have internet access. We are talented and smart human beings. So the uprights are where a football player will kick the field goal through. And that base of the uprights is 10 yards, okay, 10 yards from the goal line. So this right here is the goal line. He then walks out 10, 20, 30, 40, 50. He then walks to the middle of the football field. That's the 50-yard line, okay? So this distance that he walks out to is 50 yards away. This is where Tom is standing. He uses his little device, and when he's holding it, it's 5 feet above the ground. Again, drawing is not to scale because he's basically half the height of the uprights, and pretty sure that's not too great. So from his little machine, which is 5 feet above the ground, he measures the angle of elevation. we're looking for this height over here. This is more or less a 90-degree angle as long as this thing is standing up straight. The angle of elevation is between a line of sight or horizontal and this side right over here. Angle of elevation, theta, is right in here in this little pocket, equals 8 degrees. Just shy of 8 degrees, but we're going to use 8 degrees. Now, how far away is Tom standing? His overall distance is 60 yards, or since the problem says to use feet, we could change it now. How many feet are in 1 yard? 3. So how many feet are in 60 yards? 180 feet. What we're going to do is we're going to basically be solving for this piece right here. Once we know how long this piece is, we're going to add it to the 5 feet of height that was not accounted for and get the total height of the uprights. You have to rewind that to hear it again. Go for it. So Tom is 5 feet up. We're not accounting for this 5 feet of distance here. We're going to solve for this using trigonometry, and then we'll add it to get the total height. This picture has a lot of information on it, and doing a picture like this could be entirely way too overwhelming. I only did it one time just so we could see just really how much can go into something like this. What I would recommend instead is drawing a totally simplified version of this picture. Again, like example 1, I definitely would not even bother drawing this to scale. Let's take a look. Now, which trig function do I need to use? I have the opposite and I have adjacent. I mean, I don't really have it, but it's what I'm looking for. Opposite, adjacent. The trig function I need to use is tangent. Tan of theta equals opposite over adjacent. Now, let's just fill in what we have. Tan of 8 will equal x over 180. We want to solve for x. This is very similar to the last example, so we'll multiply both sides by 180. Again, that right there represents an exact answer, but we want to round to the nearest foot. I'm going to type it into the calculator just like we did before. 25.29. Now, if x equals 25.3 feet, because 180 was feet, for now I'm just going to round. If that's what x is equal to, and we also have to account for that extra 5 feet, and we need to round to the nearest whole number, how tall is the upright? The height of the upright is approximately 30 feet. Example 3. You are standing 350 yards from a rocket that is preparing to take off. The angle of elevation to the top of the rocket is 19 degrees. Rounding to the 10th place, how many feet tall is the rocket? Again, you can draw an elaborate drawing or you can just draw a triangle. I'm going to try to keep it basic. We're just going to analyze which sides we have, or which side don't we have? Which side is not involved? Which side are we missing? Let's look at the mnemonic device and sort of just take it from there. The mnemonic device was SOH CAH TOA. We are missing the hypotenuse. We don't have it. It's not involved. So if that's not involved, we're not using sine and we're not using cosine. We must be using tangent. Tan of theta, first I'm going to write the formula, equals, there's TOA, opposite over adjacent. Do we know theta, opposite, or adjacent? We should know 2 out of the 3 things. Do we know theta, opposite, or adjacent? We should know 2 out of the 3 things. Tan of 19 degrees equals r, the rocket, over, here's another thing, how many feet? So let's change 350 yards to feet first. We're going to multiply by 3, and that'll give us 1,050. We're going to multiply that 1,050 right on over, so 1050 tan 19 degrees will be the height of the rocket. Punch this in our calculator. No tricks for this one. I don't know why I wrote times this time. It really doesn't matter. And I think we said to round, yeah, to the nearest tenths place. So 361.5 feet. The rocket is approximately 361.5 feet tall. And that's all there is to it. We have 2 more examples to do. Serafina is flying a kite to which the angle of elevation is 72 degrees. How long is the string on the kite if the kite is flying 31.4 meters above the ground, round to the nearest tenths place? Okay. If the problem gives you measurements in meters and doesn't tell you to change anything, then we're going to leave the answer in meters. That's one thing. Next, we are also going to, just because we haven't done one yet, we're going to talk about the angle of depression when we draw this problem as well, because a lot of times there's a lot of confusion surrounding angles of elevation and depression, and people keep sticking the angle in the wrong place. So let's get drawing. Here I've labeled the details that are given in the problem. The kite would be up here. The string is between Serafina and the kite. Serafina is down here on the ground. Here is the height of the kite, and that's, again, the string. Now, I also went in and labeled our angle of elevation. It's how far you lift, you elevate to see that line between the line really is the hypotenuse. So you're going from the horizontal to the hypotenuse. The angle of elevation is how far up you're lifting. The angle of depression, however, if it were in a problem like this, the angle of depression would be if a ladybug is riding on the kite, the angle of depression for the ladybug looking down to Serafina would actually be 72 degrees as well, because this is the angle of depression. And the angle of depression is congruent to the angle of elevation. The angle of depression is how far you tilt down or sweep down from the horizontal to get to the hypotenuse. And every horizontal line is parallel to every other horizontal line. So that means the angles of depression and elevation are going to be congruent angles. So this angle right over here and this angle right over here are congruent. They are alternate interior angles. The angle of depression is never between this vertical line and the hypotenuse. That is not your angle of depression. So if you see that in a problem, please do not put angle of depression. Don't put it here. Angle of depression, if you're not sure, think about where would the angle of elevation be and make it alternate interior. Okay? So from here, we're going to fill in our measurements. The angle of elevation, theta, still that angle over here, that equals 72 degrees. How long is the string? Well, I'm going to use X instead of S because S's look like 5s. How long is the string if the kite is flying 31.42 meters? So H, not to be mixed up with hypotenuse, equals 31.4 meters. We can do what we did before, and we're going to look at the mnemonic device and then use the trig function that has the 2 sides we're working with and eliminate the other 2. H is the opposite side. The height is the opposite side. We do have that one. The string is our hypotenuse. This highlighter is maybe just a little too bold. And the green side is adjacent to the angle we're working with. I don't have the adjacent side. So the trig functions that deal with the adjacent side need to be eliminated. This means we're going to use sine for this problem. Sine of theta equals opposite over hypotenuse. Now we'll fill in. Sine of 72 degrees equals 31.4 over x. This is the kind of problem that people really tend to mess up. When you're solving for an x that's in the denominator, things are not what they seem. I watch way too many people do this, where they divide by 31.4 and they think they're done. That is not true. If you divide by 31.4, you will not have the answer. You will have the reciprocal of the answer. I want you to repeat that. If you just divide by 31.4, you will not have the answer. You will have actually the reciprocal of the answer. The reason that this happens is x is in the denominator. You will not have x alone. You will have 1 over x. You can't magically pop x up the other way. So some of you may choose to do this. Sine of 72 over 1. Then the product of the extremes will equal the product of the means. We're going to do this type of multiplication. So x sine 72 equals 31.4, and then we divide by sine of 72. That's it. When this happens, the 1 does not change that 0. You don't write 33, you write 33.0. If it says round to the nearest tenths, you give that decimal place. The string is 33.0 meters long. Now I just want to show one other thing. If you did sine of 72, then you divided that by 31.4, you don't get the right answer. I promise you. Come look at this again when you have to solve for an x in the denominator again. You don't get the right answer. There is a trick though. If you know you have the reciprocal of the answer, because that is really 1 over x equals that. Most calculators have a reciprocal button. It will either look like 1 over x, or like on this calculator, it'll be an x with a little negative 1. I'm going to press that button and it flips it over and I get the right answer. But don't mess with that if you don't understand what it is that you're doing. From a 130-foot observation tower on the coast, a coast guard sights a dolphin in distress. The angle of depression to the dolphin is 14 degrees. How far is the dolphin from the coast? Round to the 100th place. We're going to start this problem, like the others, by drawing a fairly simple picture. The observation tower is apparently 130 feet in height, so that's this line right over here is 130 feet. The angle of depression is 14 degrees. How far is the dolphin from the coast is this distance. We don't know, and we're trying to find. And keep in mind, if the angle of depression is 14 degrees, which can be found here, not here, that means the angle of elevation is also 14 degrees. So you can draw this picture in more than one way. Now we want to solve. We have, if we look at it this way, this angle right over here, we don't have or need the hypotenuse. Which trig function should we use if we have no use for the hypotenuse? Tangent. The tangent of theta is the opposite over the adjacent. Now we fill in. Theta is 14 degrees. The opposite of 14 degrees, whether we look at it from this triangle here, or if we even think of it as this triangle here, these are just turned upside down. Opposite is the 130-foot tower, and the adjacent is x, which is what we're looking for. So here we have another denominator situation, so we need to be careful. We're going to use our means and extremes. So the product of the extremes. It's also important to use the degree symbol because the other measurement I spoke about in the previous lesson, radians for angles, radians actually has no unit. So when you don't write the degree symbol, we're actually unintentionally writing radians. So you definitely want to write the degree symbol every time if you want to be proper. X times the tan of 14 degrees is equal to 130. We're going to divide both sides by the tan of 14. Now, another thing I feel inclined to mention, 130 does have units. 130 is in feet. When we find the tan, the sine, the cosine, any trig function of an angle, our answer is a ratio, and we said that ratio doesn't have units. And that's why the units of feet will carry over onto x. So it'll be feet over nothing, which is feet. We're going to go ahead and type that into the calculator. You should definitely try it first on your own because, like I've mentioned, the number one reason people get these questions wrong is they don't type it in the calculator correctly. So the answer is x is, and it's said to round to the hundredths. That's 2 decimal places out. Again, we see that we will have a 0 there. You have to write it, okay? The dolphin in distress is 521.40 feet away from the coast. So that's the end of this example. I really hope that you take some time to really practice your trig ratios, that you practice punching these things in a calculator. I hope that you practice the difference between angles of elevation and depression, and really don't underestimate just how powerful it is to learn how to draw pictures of a word problem on your own. I've been drawing them for you here, but you're going to have to draw a bunch on your own in the future, and in the very near future, and it's challenging. It's really not that easy to do. Good luck. I hope you have a lot of success on all your future examples of solving trig word problems for a missing side. Bye.